Greetings, welcome to Inference for Categorical Data Part 4. So in this part we're going to take a look at, again, something that is timely. It's kind of been in the news, and take a look at exercise 6.14 about whether or not the Civil War is still relevant in American politics or not. Okay, does it have anything to do with flags and such not in our lives or not? So let's go take a look in our studio. I've already put in exercise 6.14, cut and pasted it. You can do the same. Obviously remember that it's really easy to cut and paste from the PDF files right into RStudio, so you don't have to type in the questions in here. It makes it easier for all of us, myself included. Okay, so the Civil War National Survey conducted in 2011 among a simple random sample of 1,507 adults shows that 56% of Americans think the Civil War is still relevant to the American politics and political life. Conduct a hypothesis test to determine if these data provide strong evidence that the majority of Americans think the Civil War is still relevant. Okay, so we have to do our hypothesis test as usual. Of course, we're going to check our success failure criteria and all that as we go through here, but just a quick talk about the majority. What majority means when you see that when they're talking about hypothesis testing. It's very simple. What we consider, well, it's pretty straightforward once you get the idea. We would say that a majority has got to be what? So a majority has got to be greater than 50%. That's basically what we mean by that. So in the case of we're testing to see if there is a majority, well, the null hypothesis would say, well, no, the population proportion here is equal to 50%. In other words, we'll give you that, it's split 50-50, but there's no majority. It's either way. It's either yes or no, but it's not in favor of one direction or the other. Where the alternate hypothesis in this case would say that, well, no, there's a majority, so the population proportion is greater than 50%. Okay, so what that would say in context here is what? That would say that that Americans, there is not a majority of Americans, so no majority. That's an R there, really. And then down here is that there is a majority. Yeah, my handwriting is getting rather sloppy. Sorry about that. Okay, I think I left my T off up there even. All right, so hopefully that idea makes sense. Let's go back over into RStudio and let's start typing up this stuff, because we're going to go through all of the steps of the hypothesis test that we need to do. So the first thing that we're going to do here is we're going to come down and state our hypotheses, and we're going to check the assumptions of the test. Okay, so we want to state the hypotheses. So what are our hypotheses here? Well, let's see. So let's go ahead and we'll do as we've been doing before. I'm going to do a little bit of LaTeX here. So the null hypothesis is that P is equal to 0.5 or 50%. Okay. And then the alternate is that the P is what? It's greater than 50%. So you just use a simple greater. So you need greater than or equal to. No fancy schmancy stuff here. 0.5. Okay. All right. So we need to also check our assumptions. Okay. So check assumptions. And what are the assumptions that we need to check? Well, we need to see is n times p and n times 1 minus p. In other words, check your success failure criteria. And you see that what? Well, P here is 50%. Well, 50% of 1,507 is greater than 10. Okay, and this is going to be 50% for both. And we're doing a hypothesis test, so our success failure criteria is based on P of the null. Okay, so success failure criteria, the sample size is large. How about we just leave it at that? Okay, because I mean, I don't really need to do the arithmetic. I know 50% of 1,000 is around 500, and it's larger than 10. That's the main thing. Okay, so they're both greater than 10. That's the big deal. All right, cool. So we got the null hypothesis stated. So what's the next thing we need to do? Well, we need to make our decision rule, right? So we're doing a hypothesis test. We're going to stick to the criteria or the mode, so to speak, that we've been working with here. So our decision rule, and our decision rule is we're going to reject HO if what? If the p-value is less than 5%. In other words, we'll stick with our standard decision rule. Don't have to do anything fancy here. They didn't give us one, so we'll just go with that. Like I've said in the past, if they don't tell you what your decision rule is, then roll with the 5% criteria, okay? All right, so III, part 3 here. So in part 3, we need to calculate our test statistic and our p-value, okay? So what is the test statistic? So test stat and p-value. So we need to do those, and so we're going to need to open up an R chunk to go ahead and take care of this, okay? So let's go ahead and get an R chunk going, because this is where the actual rubber hits the road. We're going to do some mathematics here, all right? So we need to, first of all, we need to calculate what the z-score is going to be based upon this. So how are we going to calculate that z-value? Well, our z is going to be equal to what? Well, it's p hat minus p naught divided by the standard error, which is going to be based on p naught, okay? So I'm going to do this a little longhand. You don't have to do it this way if you don't want to, but I want just so you can see all the pieces with their names on them. I think it might not be a bad idea. So p hat is the sample value, okay? And it was 56%, so p hat is equal to 0.56. P naught, which I'm going to put in as p0, p0 is equal to 0.5. That's the null's value. In fact, let's put a 0 in front of them here just to help you see it, okay? Okay, so that's those. And then what's n here? What is our n value? Well, n, that was equal to what? Well, let's see, how many did they do again? It was 1,507. So 1,507 is what our n value is going to be, all right? Okay, so now that's all the pieces that I need. I just need those three numbers to construct my z. So let's go ahead and construct my z here. So this is my test statistic. So z is going to be equal to the difference between p hat minus p of the null, or p0, and then that's going to be divided by my standard error, which is SQRT, the square root of, okay, now when I'm calculating the standard error in a hypothesis test, I'm going to use the null's value. So that's going to be p0 times 1 minus p0, all of that divided by the sample size, which is n. Okay, so let's go ahead and run that chunk just so we can see what happens there. Okay, and so we get the following, and if we look over here into our environment window, we can see that the z-score came out to be 4.658, blah, blah, blah. That's a huge z-score, which what that's telling us is that we're very likely going to be rejecting the null hypothesis, because that z-score is big, all right? So as a matter of fact, let's go back over to the whiteboard for a minute, and let's use the whiteboard for a moment to draw ourselves the distribution of the standard normal to help us see how we're going to do that calculation, all right? So here is the distribution of the standard normal, which is z, and our observed test statistic was way out over here at Cleveland. It was back over here at, like, 4.65 roughly, something along that lines, right? So 4.65. Okay, now recall that this is a one-sided test here. And in a one-sided test, we do not double the p-value. That only happens at a two-sided test, because fair criteria is that if you're going to set your level of confidence from both sides, you have to do your p-value from both sides. But in our case, we're not. We're just doing a one-sided to the right. And remember that when you're doing a one-sided test, the inequality symbol that shows up in the alternate hypotheses can be thought of as an arrowhead telling you the direction you need to shade in order to calculate your p-value. So my p-value is going to be that red area right there. And we can see already, because we know by the empirical rule that 99.7% of all the data was within plus or minus 3 standard deviations of the mean. That that's above 3 on the z-score. that's going to be basically 0, isn't it, right? So we know that that p-value is going to be approximately equal to 0, but we'll go ahead and let RStudio calculate that for us, all right? But we know up front. So in some of the quizzes, I've noticed folks have had issues when you have large z-scores and they've come up with that the p-value was 1, and it's because you're not drawing your picture. Stop and draw the picture and think about it intuitively before you run to RStudio to go do the calculation, okay? All right, so let's go ahead and see. It's going to be a 1 minus p norm, or you can do just put a false in there if you want to. I know some folks have been doing that, and that's totally styling also. Now listen, we've already calculated z, so let's just put it in there. We don't have to copy it back in, and we'll put a 0 and a 1, right? Okay, so let's go run that chunk one more time. And come down here, and we notice that our p-value is incredibly small. There are 5 zeros in front of that 1. Remember what that e negative 0.6 means at the end? That's times 10 to the negative 6, which means you're dividing by a 10 with 6 zeros over it under that number. So that moves the decimal point 6 places to the left is the way to think about it. Okay, so all right, cool. Let's continue on. We now know what our test statistic and our p-value was. So the next step in a hypothesis test, once you know those values, is to make your decision, right? So make your decision based upon the data. And since the p-value is less than 5%, we reject the null hypothesis. And so you can put that in if you want to. I'm going to get fancy here and put it in as an HO. Okay, we reject HO. All right, so last step of all hypothesis testing is to state it in context, okay? In other words, tell your mom what this means. Don't just tell her that you rejected the null hypothesis. She's not going to understand what you meant. You got to give it to her in terms of a conclusion. So in other words, tell us what all your hard work, what the fruits of your hard labor were, okay? So the conclusion is going to be what? Well, the data provide convincing evidence that the majority of Americans still think the Civil War is relevant to politics. War is relevant to U.S. politics. So that's what it comes down to, okay? All right, now, they would like us to also say something about the p-value in context. What does the p-value mean in context here? Okay, so you got to remember that what we meant by the p-value, what the p-value tells us, is the p-value is basically the probability of type 1 error, but this time based upon observation, not based upon a decision rule. And so what we're seeing here is that we've got a probability of seeing 1,507 Americans thinking that, in a random sample of those, that thinking that 50% or 56% of those thinking that the Civil War is still relevant. The probability of finding that in the null hypotheses, or more extreme, that the probability of that was basically 0. So the probability of seeing 1,007 Americans or more thinking the Civil War or is relevant in the distribution of the null is about 0. That's basically what we're saying when we calculate the p-value. We're saying that the probability of seeing that value or more extreme in the distribution of the null was about 0. Okay, last but not least, they want us to do a confidence interval. This is a really good problem in that sense. They want to contrast what we just did with the hypothesis test with a confidence interval. So now they want us to make a well, here I'm making my own A, B's, and C's, and they're already in here. So let me get rid of that one. Let's go down here, and I'll just do a little cut and paste here. There we go. It's a problem when you do too many of these videos in a row. Your brain starts to get all squashed between them. Okay, here we go. All right, so calculate a 90% confidence interval for the proportion of Americans who think that the Civil War is still relevant. Interpret this interval in context and comment on whether or not the confidence interval agrees with the conclusion of the hypothesis test that you just gloriously did. Okay, well, so big reason why I'm really like this problem when they did this is the contrast is that when you do a confidence interval, you no longer are using a null, you don't have a null hypothesis. That's not a part of the game anymore. Now what I'm trying to do is get an interval estimate. I want to estimate what I think the population proportion of Americans are that believe the Civil War is still relevant to American politics, okay? So what that means is you need to use p hat and not p0. Okay, when you're doing a confidence interval, you're doing it based upon your point estimate, which is p hat. Okay, so most of this is basically in an R chunk. So let's go ahead and put that in because we need to just come in and do some calculations here. So again, as in the previous time I did a confidence interval, just to show you the structure, I'm going to go ahead and type out what the values are. So p hat is going to be equal to 0.56. Okay, again, you don't have to do it this way. You can just put the numbers in, but I think it helps kind of drive home what's going on here. So I'm going to use U for my upper limit on my confidence interval, and that's equal to p hat plus, okay, now we'll see what was my, I mean, we could go in and actually use P or Q norm to figure out what the value of Z is, but we've only been using 95% and 90% confidence intervals with Z-scores for a reason, because those numbers are easy to memorize, and so that's a 1.65. So 1.65, and then put in a times here, and now an SQRT. And now what is that going to be? Well, that's going to be P hat times 1 minus P hat divided by our sample size, which is n. Ooh, let me come up here and define n again. Although we already did it earlier, I'm going to do it one more time. So that's 1507, just so you see that that's still the same n there. So I'm going to come in here and that's don't want that division there. I wanted it there. I'm glad I stopped and caught myself there. Okay, so it's p hat times 1 minus p hat divided by n. That is going to be our upper value, and to get the lower value, come down here, just a copy and a paste, and change the U to an L. And this time, unlike my last video, I'm going to remember to do my C, my vector with a U and an L this time. So that's C with an L comma U, all right? And so that should give me the confidence interval. Let's run that chunk just to make sure I didn't mess up. And there we go. Okay, so our confidence interval is between basically 53.8% or 53.9, excuse me, 53.9% and 58.1% of Americans still feel that the Civil War was relevant. But of course, we've got some boilerplate with that. So we say with 90% confidence, because we're using a 90% confidence, between 53.9. So at this point, I'm going to switch back to percentages because I'm reporting it out. And when you report out, most people deal better with percentages than they do with decimal numbers. So it's a good idea to switch back to percentages at this point. And 58.1% of Americans believe that the Civil War is still relevant to U.S. politics. Okay, all right. And given the current stuff that's going on in the news, I would say that totally makes sense. Okay. Now, does this agree with our previous conclusion from our hypothesis test? And the answer there is yes. 50% is not in our interval. So we have collaboration between our confidence interval, which is basically if we'd done a two-sided test instead of a one-sided test, we still would have rejected null hypotheses using a p-value using an alpha of 10%. Okay. All right, a lot to digest in that problem. Definitely if you need to watch this thing a couple times, make sure that you follow along, and I'll see you back here for the next one.